discussing sum of products. That means when you have Boolean expression, we can write in a particular format. So when you write this Boolean expression as a sum of products, that means using AND operations, then we will call it sum of products or SOP. Boolean expression එකකදී අපි විශේෂ ක්‍රමයකට මේක ලියනවා නම් මේ එකතු කියන්නේ products වල එකතුවක් විදිහට අපි ඒකට කියනවා sum of products කියලා. Now for example, if you say A B bar C D bar plus A B bar D plus C D bar plus A D bar. එතකොට මේකේ පේනවා අපිට sums ගොඩක් තියෙනවා. මොකද ගුණිතය තියෙන්නේ. sorry products තියෙනවා. ඊට පස්සේ ඒ ටික sum කරලා තියෙනවා. අපි එතකොට එකට sum of products කියලා කියනවා. Now when you have a special case which we call standard sum of products, අපි විශේෂ අවස්ථාවක් කියන standard sum of products කියලා. That means if all the variables are present, right? Now in previous one, if you look at carefully, we have 4 variables A, B, C, D, but not all the sums, we don't see all the variables. But in an expression, if you can see all the variables, then we will use a special name, standard sum of products. කියන්නේ standard sum of products කියලා කිව්වහම හැම variable එකක්ම අපිට මේක පේන්න තියෙනවා නම් අපි ඒකට standard sum of products කියලා කියනවා. Right. Now the first thing that we need to learn is when you are given a sum of products, how do you convert to a standard sum of products? දැන් අපිට අර කලින් දුන්නා වගේ හැම විචල්යක්ම මේ expression එකේ boolean expression එකේ තිබුණේ නැති වුණොත් අපි කොහොමද මේක ගන්න කියන එකයි අපි ඊළඟට කතා කරන්න යන්නේ. එතකොට මේකෙදි අපි දැනගන්න ඕන දේ තමයි කොහොමද මේ missing variable එක මේකට ගන්න කියලා. හරි සරලයි. ඒකදී දැන් උදාහරණයක් ගත්තොත් පොතේ A B bar C plus A B bar plus A B C bar D කිව්වොත් අපි missing variable එක වෙනම දානවා. අපි දන්නවා දැන් උදාහරණයක් විදිහට දෙවෙනි term එක ගත්තාම ඒකේ C missing. අපි ඉස්සෙල්ලා C දාලෙමු. දෙක එකපාර ඔක්කොම කරන්නේ නැහැ. So අපි C දාලා තිනවා. අපි දන්නවා C plus C bar කියන්නේ එකයි. හරි. නිසා AB bar වලට අපි C plus C bar දානවා. එතකොට මේක multiply කරගත්තාම term එකක් එනවා. එතකොට AB bar C plus AB bar C plus AB bar C bar. දැන් ඔයගලන්ට පේනවා පුතේ මේ දෙක මේකයි මේ දෙක එකට එකතු කරන්න පුළුවන්. මොකද මේක නිකන් හරියට A දන A වගේ. ඒතර එකම අගේනේ. හරි. මේකයි මේකයි. දැන් අපි දන්නවා D missing. එතකොට මේ පළවෙනි එක ගත්තොත් A B bar C D missing ඉඳන් අපි D දාලා D plus D bar plus A B bar C bar D plus D bar. එහෙනම් අපිට මෙන්න මේ විදිහට අන්තිම උත්තරේ එනවා. මේක අපිට ලීසින් ගන්න පුළුවන්. right. අද පාඩම පටන් ගන්න කලින් body exercise එකකින් පටන් ගන්නවා. Let me give you an exercise. Right. Convert this into right. මෙන්න මේක මට හදලා වන්න පුතේ WhatsApp එකට. I want to convert this sum of products into standard sum of products. Let's start. Right. Now, what we were discussing last time at the end is how to construct sum of products from a truth table. දැන් මේ අපි යන්නේ පුතේ circuit design කරන එකේ පළවෙනි තැනට. මොකද මේ පළවෙනි තැන කියලා කිව්වේ? Now we know how to design a truth table. Truth table එකක් අපි ගන්න දන්නවනේ. එතකොට මේ truth table එකෙන් හරි අපි කොහොමද මේ boolean expression එකක් ගන්නෙ කියන එකයි කතා කරන්නේ. So to do that, the first rule is once you have a truth table, you look for only ones, right? So in this truth table, we can identify 4 ones. And then look at what are the values here. If it is 1, you take the variable as it is. If it is 0, then you invert it, right? So for example, here, this is 0. So you take the inversion of A. So that means A bar. Here also 0. You get inversion, we get B bar. Finally, we have C. So for representing this 1, we take A bar, B bar, C. Similarly, here we have 1, 0, 0, and this is 1. එතකොට මේකේ එනවා A, B bar, C bar. මේ 1 වලට ගත්තොත් A, B bar, C. මේ 1 වලට ගත්තොත් A, B, C bar. Finally, මේ අපිට ආවේ products terms ටිකක්. මේවට අපි product terms කිය. We put sum. So final is if we can write down as a Boolean expression A bar B bar C plus A B bar C bar plus A B bar C plus A B C bar. 4 terms එන අපිට මේක කතා කරන්න පුළුවන්. හරිද? Right. Okay, next look at how we can have products of sums. Now for that, I'm going to use the same truth table, right? So which is easier for me to discuss. So let me copy and paste here. Sorry. Right, let me start with this. And, I'm going to get these lines also. Right. So now let's discuss how we can do the other way around, that is product of sums. So in product of sums, what we do will focus on zeros, right? Now instead of previous one, in the previous one we had, right? In the previous one we had ones, we focus on ones. Now here we are going to focus on zeros, right? Like this. Now, for example, here the first zero. Yep. So when you're writing product of sums, we will look at zeros. So here also we have another zero, another zero, another zero. And rules like this, we look at all zeros, right? And what we are trying to identify is sum term, right? And when you write it, right? So remember that what we do when we have zero, we take the variable as it is. If it is one, we will get the complement, opposite of the previous. I will repeat. Now, when we say the sum, right? If you have zero, we'll take as it is, like this. So for example, here zero, we'll take the variable as it is. We will take the term as A plus B plus we have C. All are zero. It's something similar to this. It's like 0 plus 0 plus 0 is 0, something like that. Here also similarly, when you want to multiply, when you want to get 1, we know we have to get the complement, then we'll get 1. This is also get 1, and then what? Similar to this one. Right? Kanta, can you tell me like what is the term here then? Zero na variable like 1 na
B bar C.
Right. So we have
A plus
A plus
B bar plus
B
C.
bar. Yes, we have B bar plus C. Right. That's it. Movinia, next one.
A plus B bar plus C bar.
A plus we have B bar plus C bar. Yes. And final one, we know that it's A bar plus B bar plus C bar, right? So the term, we can write it like this, then we can take what is F, right? We can say the F equals, in other words, we can say F, when we say the term, we can say, F equals, we can say, in other words, we can say, okay, how do you put, like we can say A plus B plus C into A plus B bar plus C into, right, A plus B bar plus C bar into A bar plus B bar plus C bar. Right? So the rules you can write down similar to previous one. Rules. The first one is for all 0 in the output F, we need to find the sum term, this time sum term, right? And the second one, if the input is 1, then invert the variable, and 0, then take the variable as it is, right? So that we have already done. The last point is the third one. All the sum terms are connected using product. That means AND. Okay. So this is what okay, you can take down. So far, we looked at some of mean terms and then product of now we use sum of products and product of sums, right? So these are known as, although we have written like this, these are known as min terms and max terms, right? Let me explain this first. And then we will discuss how can we the sum of products and product of sums, right? So we'll look at that first. Right. So let me put in this the same table I'm going to use, but without F. Without F, I'm going to write down all possibilities, right? So let me take let me do this one first. I will copy. What is going on? I cannot copy this. Right. Okay. So the topic that I'm going to discuss is called mean terms and max terms, right? And the relationship. That's what exactly I'm going to discuss, right? What we are going to discuss is mean terms and max terms. Now, these mean terms and max terms are used to represent these two things. It's the same thing, but we will use it slightly different way, right? So let me explain that. Now, when we talk about mean terms and max terms, I'm going to remove F because, yeah, I'm going to look at this as mean term, Now, here what mean term is product terms, product terms, right? Here mean term means we'll look at product terms. And then I'm going to look at the next one. As the next one, I'm going to look at max term. I will explain what max term is. Max term. Right. So the max term is we call sum terms. Right. So how do you represent this? We have already learned this earlier, but I'm going to look at all possible combinations so that you are comfortable with the next sessions. So what I'm going to do, the first one is min term. Now min term means the minimum value. That means let's assume that outcome is 0. It's a minimum value, right? So to outcome we have 0 product terms. That means we will look at product terms means let's assume that outcome is 1. If it is outcome is 1, we have already learned. So that is we have to get it as A, B bar and C bar. Similarly, if you look at sum term, then you take the variables as it is A plus B plus C. So here we assume the outcome is 0. Similarly, here we will have again the min term is A bar B, dot B bar dot C. But if you look at sum term, then we know that we'll assume the outcome is as 0. If it is 0, we know that we have to say, A plus B plus C. පුතාලට තේරුණාද මම මේ කියන්න හදපු එක? කියන්නේ අපි අර කලින් එකම තමයි. හැබැයි මෙතනදී output එකක් ගැන හිතන්නේ නැතුව all possible combination බලනවා. ඒතර product terms වලට අපි කියනවා විශේෂ නමක් min term කියලා. Sum terms වලට we call it max terms. Now to get the min term, we'll assume the outcome is 1, right? And then we discuss that when you have 0, you will get the complement and you multiply them. Similarly, for some terms, we assume that we have 0, and then we'll try to add like this. Right. ඉතුරු ටික පුතාලට තනියම පුරවන්න පුළුවන්ද එහෙනම්? කාන්ත? Right. Let's start then. Can you fill and send it to me WhatsApp? Use a Karnaugh map to simplify this. In Karnaugh maps, what we have discussed so far is how to simplify using sum of products, right? Product of sums we have not done. Right? So in that sense, we can put the values. So 0, 0, 0, we know outcome is 0. Then 0, 0, 1, that is 1. Then we have 0, 1, 0, that is 0. Then 0, 1, 1, that is also 0. Then 1, 0, 0, this is 1. 1, 0, 1, this is 1. 1, 1, 0, this is 1. And then this will be 0. Right? This is what we have. Now the question asks, and we'll try to, simplify this. So can you simplify and let me know what is the answer for this one? You can have you can have 1, 2, 4, right? So we try to first form 4, try to simplify, but you can find 4 together. So you can identify some 2's, like for example, this one very clear. This is 1, right? And this is another one. If you want, you can try. But then there's another one here, right? But remember that we have identified 3 groups, but you don't need 3 groups to cover everything. But using this one, right, this one, and using this one, that is, we can cover everything, isn't it? Right now we have 3 terms, but you don't need 3 terms here, right? Remember this, very important, right? We can identify 3 regions, but you don't need 3 regions to cover all ones in this one. So the best answer would be, the number of regions would be, I can go back and show you, right? So the best one would be this one, this region, and this region just by combining these two. Agreed? Howini haridද දැන්?
Hari.
So the reason is, yes, you can identify two groups, but the problem is we try to minimize. You don't need like all the three. By using only two, we can cover all the ones. So that's the necessity. So now can you tell me what is the expression for this one? This region, what is the expression? We know that A is changing so that we can ignore A, and what we have is BC. So when you see BC, that means we'll take B bar C, right? Are you in agreement?
Yes.
Similarly, this one, can you tell me, Kanta?
AC bar.
Yes, we have A because A will not change. And then if you look at the next one is actually C. So that is C bar, right? Is it AC bar? So simplified expression, we can write like this. Simplified sum of products SOP expression using Carnot map, right? So this is using Carnot maps, right? So what is the simplified expression? We can say, yes, Mavinia, F equals
B bar C
B bar C
plus A C bar.
plus AC bar. So this part you should know by now, right? We have already done. We know our original one, right? Our original one using sum of product is like this. This is our original one. Now we were able to reduce this is to this. Okay. Right. Now similarly, we could have used product of sums as well. We have not done this earlier, but we could have done product of sums as well. Now, can you tell me if you want to simplify using product of sums, which ones we should focus on? So sum of product we focus on ones. Yes.
0.
We have to look for zeros. Yes. We didn't discuss this in earlier because I don't want to confuse you everything. So now let me explain how we can use Carnot maps, right? In both ways, Carnot maps using both ways to identify, right? identify this. Okay. So what I'm going to do is I'm going to compare the same Karnaugh map. In our case, we have three variables using sum of products and product of sums. Okay. So if we look at sum of products, we already discussed this earlier, right? That we will take it like this. So how do you take it like this? So now we know how we can put this using a product of sums. Right? So in our case, right, this is what we had. This is what we have, sum of products. Now I want to do the same using product of sums. Now you know we have to focus on zeros. But let me tell you like how to get the simplification as well, right? That we need to understand, right? So I'm going to use the same Karnaugh map, right? But how do we get product of sums, right? That's the first thing. So in product of sums, we need to understand what is inside. Yes, we need to understand what is inside. So let me select this, right? I'm going to, increase the size bit. Yes, so that I can write down the expressions. So now this is sum of products. Can you tell me what is the product of sum here? When you have 0, 0, 0, what is the product of sum? That means max term. What is the max term when you have 0, 0, 0? We have already learned when you have 0, 0, 0, what is the max term?
A plus B plus C.
Exactly. So here the max term is we can take A plus we can take B plus we can take C. Right. Similarly, let's try one more. Kanta, can you tell me what is the max term for this one? 0, 0, 1.
A plus B plus C bar.
Yes, this should be A plus B plus C bar. Right? So similarly, I can say, okay, A plus, right? I can say, okay, it should be B bar plus C bar. And here also we can have A plus B bar plus C. Okay, can you draw this? And similarly here also, right? We can see, okay, now what we have, that is A bar plus B plus C. So here A bar plus B plus C bar. Here A bar plus B bar C bar. And here A bar plus B bar plus C. Right, now let's try to simplify using the same principles. So that's why I didn't go through that as earlier, because you can make use of whatever you have learned so far. So what I'm going to do, I'm going to select only zeros, right? That's what I'm going to do, isn't it? Right, now that I can use same way, but this time I'm going to select only zeros. So I will remove all the regions, because we know what we have to do. Now, instead of selecting, right, ones, we can have zeros. So you can see here, we have one region and we have another region. So this is the two regions, right? I will give you time. Can you tell me what is the simplified term here? A is not there, 1, 1. What is 1, 1 then? You know what is 1, 1. Yes,
B
Mavin.
bar, C bar,
B bar,
C bar
B bar. Is it
plus
B bar?
C bar.
Yes, it should be B bar plus C bar. So the term for this is now becomes B bar plus C bar. Similarly, Kanta, can you tell me the expression for this region?
A plus C.
Yeah, that should be
A plus C.
it should be A. That is true, because 0 plus, then what is changing is C, again C, A plus C. Good, I think, yeah, pretty good. So now we can say, same way, the simplified product of sums. We can say, okay, simplified product of sums. Sorry. That means POS expression using Carnot map. Using Carnot maps is, yes, can you tell me the final answer? F equals what?
B bar plus C bar
Yes, we have B bar plus C bar into
C.
A plus C. Good. So this should be the answer. Okay. Can you take down this?